Well, hi, this is Han-Jia from Lambda, Nanjing University, China. Here goes a brief introduction to the work that what makes objects similar, a unified multi-metric learning approach. The nature of linkages between objects are essentially determined by similarity measures that may be derived from multiple perspectives, and the linkages lie in various areas, for example in social networks, images, and texts. Except for spatial linkages generated based on localities of heterogeneous data, there are also semantic linkages can come from various properties, such as different physical meanings behind social relations. Many existing metric learning models focus on spatial linkages, but leave the rich semantic factors unconsidered. Kinds of linkages make overdetermined constraints in metric learning. In order to analyze the overdetermined linkages between objects, we propose a unified multi-metric learning UM2L framework to exploit multiple types of metrics. In our approach, a type of combination operator is introduced for distance characterization from multiple perspectives, and thus can introduce flexibilities for representing and utilizing both spatial and semantic linkages. For example, when both kappas are max operator, UM2L can be used to depict complex social friendships between users in a social network. When max and min are chosen, the metric learned by UM2L can find latent linkages between partial labeled images. Similarly, when min and max are used respectively, a partial relationship can be forced consistent among different modalities. More kappas can be used, such as the average one or the indicator, in which case UM2L can degenerate to some existing multi-metric learners. The most important thing is that we have a unified optimization strategy for different choice of kappa. This is also another reason our approach called a unified one. In experiments, we test UM2L in the field of potential linkage decomposition in social networks, and latent model semantic discovery from combined multi-view dataset. The approach can also discover subtopics for conference papers, given session linkages in empirical investigations. More investigations show it does well in image weak label discovering tasks. Besides, as a metric learning method, it can achieve better classification performance with the learned metrics using 3 nearest neighbors compared with state-of-the-art metric learning methods on different scales of datasets. Thank you. We look forward to discussing with you. Please come to our poster 94 at area 5678. Thanks.